Okay, good morning. Hopefully you all saw that there was a pop-up there saying that we are going to be recording this session. So hopefully that is okay with everybody in attendance here today. I'd just like to say a very warm good morning, afternoon and evening to all of our speakers and attendees that are joining us for today's webinar. We're delighted to see you here to celebrate what is actually the second annual event that the WTUN has held in acknowledgement of International Day of Clean Energy. And we're very pleased to present today's programme, having convened 4 expert speakers from 3 of our network's international member universities to speak on the topic of clean energy and to explain their own areas of excellence and research relating to this topic. So on the subject of the UN Day for International Day of Clean Energy, the UN stated that in a world grappling with climate change, clean energy plays a vital role in reducing emissions and can also benefit communities lacking access to reliable power sources. Still today, over 385 million people live in the dark, more than 80% of them in sub-Saharan Africa. The connection between clean energy, socio-economic development and environmental sustainability is crucial in addressing issues faced by vulnerable communities worldwide. And the International Day of Clean Energy, actually on the 26th of January, was declared by the General Assembly, Resolution A77327 to be precise, as a call to raise awareness and mobilise action for a just and inclusive transition to clean energy, which will be for the benefit of people and to the planet. So a little bit about the World Technology Universities Network itself, for those of you who are less familiar perhaps. The WTUN, World Technology Universities Network, is a global network of technology-focused universities, and our diverse membership is united by a commitment to the inclusive advancement of sustainable scientific and technology teaching and research, and each of our members demonstrates a commitment to truly equitable innovation for the benefit of people and place. In brief, our WTUN members each deliver teaching, research and innovation which has a direct benefit to people and society, driving technical and social innovations and entrepreneurship, developing graduates who will become global citizens capable of leading to the future. They work closely with local, national and international government, industry and other organisations, promoting interdisciplinary cooperation and have a demonstrable impact on society. Please may I thank one of our speakers and chair for today's event, Professor Puspamitra Panigrahi, head of the Centre for Clean Energy and Nano Convergence, or CENCON for short, at the Hindustan Institute of Technology and Science, India. I will just briefly introduce our chair and speaker. Her full biography is available on the event page. But Dr. Puspamitra Panigrahi completed her PhD in physics from Michigan Technological University, MTU, in the USA in 2009 under direction of Professor Ranjit Prati. She pursued her postdoctoral research at Uppsala University in Sweden and worked as a visiting scientist at IGCAR, Kalpakkam, India. In 2014, she joined Hindustan Institute of Technology and Science, one of the WTUN members, in India as an associate professor and was promoted to professor in 2021. Currently, Dr. Panigrahi heads the Centre for Clean Energy and Nano Convergence at the Research Centre at HITS, as I said, and has also been a visiting scientist at Michigan Technological University, USA, and Dongkook University in South Korea also. Her expertise lies in condensed matter theory with a focus on nanoscale materials. Her research group collaborates with international researchers to develop smart nanomaterials for application in subjects such as energy storage devices, toxic gas and volatile organic compounds, or VOC for short, sensing and photovoltaics, and water purification, oxygen evolution, and other subjects related to this area. But as I mentioned, Professor Panigrahi will facilitate our discussion today. At the end of the presentations, there will be time for a panel discussion, and there will also be a short period of time to ask questions after each speaker's presentation. Today's session is being recorded and will be made available post-event on the WTN's website and the YouTube channel to watch back. That is all I have to say for today, other than to encourage you to please ask any questions that you have in the Q&A, as I mentioned. But for now, please allow me to introduce Professor Panigrahi, our chair and speaker for today. Thank you, Professor.
Thank you, Denise, for such a wonderful introduction. And I would like to welcome everybody to this platform. So, I am the first person to give the talk. Am I audible clearly?
Yes.
Okay. So, I will share my slide. Then we will have a discussion. And anybody wants to ask any question, you can stop me or raise your hand, or we will wait till the end of the session. Okay. So, my slide is visible to everyone.
Yes, it's visible. Very clear.
So otherwise, let me know if there is some technical hitch. So I'm once again Puspamitra. I'm from Center for Clean Energy and Nano Convergence. It's a research center of Hindustan University. So I would like to first thank WTUN for giving me this opportunity to come to this wonderful platform. And when there's a occasion of International Day of Clean Energy is getting celebrated, so we our research center mostly focuses on developing nanomaterials for clean energy towards clean energy applications. So I feel very thankful that I got an opportunity to present my work, our group's work, our center's work in this platform. It's an interesting platform from all corners of the world. We are gathered here. So this is and this first is like all of us we know that we are United Nation. We want a world, better world, sustainable world, happy world with peaceful. With that, our United Nation has given a sustainable development goals. There are 17 goals are set up for this, which starts from no poverty, zero hunger to many other 17s. One among them, the number 7, which is affordable and clean energy, which is the theme of the today's presentation. So this is what I would like to talk today. This is I will proceed my talk. So what we mean by affordable and clean energy, like Dennis already mentioned, we need universal access, that is at least electricity for all the people in the world, but only so far, well, 90% of people, they have access to electricity as per the statistics says. So we need our community all over the world, from scientist community to academics to industry, should work hand in hand to go for reliable, affordable energy. And then if we look at the current scenario on what we are depending for energy, that is fossil fuel like coals and diesel, petrol version, and which is giving rise to greenhouse gas emission. So we need to go for clean and sustainable energy. So, what is the alternate? What is sustainable? What is green energy? That is modern energy. We will look for those are like solar energy, wind energy, tidal energy, hydrogen energy, etc. But if we look at the current facts, what we are having now, we are still dependent on fossil fuels, because practical realization is still we are having challenges. So two things we have to look into: abundance of production of those clean energy, and the other factor is storage. So for that, infrastructure needs to be developed, and technology simultaneously, they work hand in hand. So out of many aspects, prospects, we have to look for clean energy. One is storage energy, because if we have, like I will describe in my next slides why it is so important, storage is so important. So one of the storage material, if we look, everybody, all of us, we know that is lithium ion battery. But why we are still looking for more alternative options? Because lithium is expensive, and extraction process is also not so environmental friendly. But we need grid-based storage, and the possible solution is sodium and magnesium ion kind of new type of batteries. This is how I will talk. So this is called the duck curve. So why I want to show it, that why storage of energy is very important. If we look at our solar energy, from morning 6 a.m. to evening 6 p.m. in many parts of the world, we will get enough solar energy. But it's not that we can directly utilize it other than our house will be lightened. If we want to utilize it as an electric appliance or other things, we have to use photovoltaic cells. So what it is saying, that it's a database of a very affluent city of an affluent country like US or Australia, where most of their rooftops are with solar cells, which converts the solar energy to electricity. So it says from morning 6 a.m. to 6 p.m., not exactly 9 a.m. to 3 p.m. So the demand on electricity, which we are using from hydroelectricity or coal or other, reduces, because year-wise, those developed countries or even developing countries, they are technically very much well affluent in developing the solar energy. But what happens after 6 p.m.? Even those countries, the demand of electricity is more. People are returning back to home from their work. They need to cook, do laundry, do AC, use AC, everything. But we are still back on dependent on fossil fuel based energy. So where is the problem? When we are having enough solar energy, we are not able to store them. So when it comes to storage, the best thing comes to our mind is rechargeable batteries, which are much better than the disposable batteries like what we used to use in the olden days. So this rechargeable batteries, we can, like what we use currently in our laptop or mobile, what we are holding, those are lithium ion battery. They can be used several times for months together. So they are environmental friendly, like all the many SDGs color you can think, see here, it qualifies. So for that, in 2019, the Nobel Prize in Chemistry went to all these three big scientists. And in 1991, lithium ion battery was commercialized. And the middle scientist, Dr. Goodenough, was called the father of the lithium ion battery. The first Professor Stanley, who first gave the idea of lithium ion battery. This is all about lithium ion battery. Then now the question is, when we have lithium ion battery, what is the problem, what we were looking for then? Then this is that the picture in the round circle, it shows all of us, smartphone, laptop, all the gadgets, we are completely dependent on lithium ion battery. And then next we are thinking about our electric vehicles, where we want also lithium ion battery. But lithium is not earth abundant, it is quite expensive. And if we want to use it as a grid storage, grid based storage means we will like to store the energy what we are harvesting from solar energy or wind energy and tidal energy. To meet that factor, our lithium supply on this planet is not enough, and lithium will be expensive. Once the energy is expensive, it cannot meet the goal of affordability. It cannot be affordable for everyone. So we need to look at the alternative solution to store those energy. Then what comes the next is where we will look for. Now we need to look for the alternative energy. Now if all of us remember till our school days or our periodic table, the next bottom atom to lithium is sodium. So just to remember the school time, I gave the periodic table configuration where how the electrons are arranged. So the outermost electron for lithium is 1, the sodium is also 1. So they are considered, they belongs to same family. But if we look at sodium is earth abundant. If you look at the right side, if we try to extract sodium from sodium hydroxide, it's $500 per metric ton. Where lithium, if we are getting from lithium hydroxide, it is $78,000 per metric ton. So it is way cheaper than lithium. So that bed, we of course sodium is behavior, but when we are going for grid storage, we are not going it using it as for laptop or any other thing. It's heavy, doesn't matter. And the other thing, the problem is lithium, it cannot store longer the charges. It cannot store for longer periods where sodium can do. But the potential, if we compare currently with the lithium, it is not par with that of lithium. Then the one of the other aspect is it at low temperature. If you want to take it where it is very cold, the stored energy, solar energy, you want to make people help when there is very cold area, lithium is not a best option battery as a battery. But sodium can withstand up to minus 20 degrees Celsius. So sodium ion battery is one of the best possible solutions. So if you look at the left hand side curve, so what is the technology they are working on to develop different alternative batteries? One of the major area is sodium ion battery, where most of the research, technology, infrastructure development, they are looking at sodium ion battery. Then the other possible solution is magnesium ion battery. If you look at the periodic table, it is the next column it will come. It is the corner wise it will touch, but it has another advantage. I will let you know in another 1 or 2 slides how the battery, lithium ion battery works. Of course, most of us know, but I will just refresh our mind that when the lithium moves from one positive to negative or negative to positive electrode, electron moves. What the current we get, that is the movement of electron. That is what we need. But in case of lithium or sodium, like I was showing you in the previous slide, only one electron per lithium atom. If one lithium is moving, we get one electron. But in case of magnesium, for one magnesium, we are getting two electrons. So the charge density will be right away double if instead of lithium, we are using magnesium. And of course, it is also fifth earth abundant material compared to uh, lithium. And it's a technical term why the atomic radius is very important. In the next slide I will explain. But many other like specific capacity, volumetric capacity, magnesium ion, if we are reaching to a practical applicable magnesium ion battery, then we will be at a best possible case to for developing a grid based storage system. But where we are now, so the first thing is why in the market we are still dependent on lithium ion battery, why not sodium or magnesium based battery, where there is a lack is happening between academia and industry. So the red dotted box shows there are the con factors, and this other side, left hand side, it shows the pro factor of those. If we want to develop a sodium or magnesium ion battery, we need to look at that. They should be parallelly good, where lithium is really good. And where we are lacking that factor, we also need to look at, so that the practical possibility realization will be possible for both the sodium or magnesium ion type battery. Of course, first thing, lithium is widely used and accepted because it's lightweight. Charge discharge cycle, that means your several quick charge, slow discharge, number of cycle is more, and operating voltage is good. These are the main factor why lithium is darling of everyone. All the industry, they depend on lithium ion battery. But lithium is always expensive, and to make the lithium ion battery, other elements what they are needed also expensive. It is temperature sensitive, and still to meet our requirement, we still need to have further research. But when it comes to sodium, the advantage is what I told. It is similar family to lithium. But the problem is sodium is much bigger in size than lithium. It will be heavier, of course, and technical issues are there, which I will discuss. Then when it comes to magnesium, of course, the pros are it will double charge density. You will get double the current. Charge, discharge rate, capacity, life cycle, these are all kind of research topics. But the most difficult part in a battery, there will be electrolyte technically, other than cathode and anode. That electrolytes are not yet developed suitably for both sodium and magnesium ion type batteries. So unnatural growth of unnecessary items happens, that is called dendrite growth. So that's why they both are still in the lab scale. Of course, sodium ion battery use started, but yet to be achieved, like to come parallel with lithium ion battery. So with now I'm coming to this normal view how the battery works. It has a cathode, it has an anode, it has a separator in between, and some electrolytes are there. So when we are charging the lithium or like sodium or whoever, the ion responsible for the battery, they will go from cathode to anode. Cathode is the material which is the host material, which will be like that material rich. If it is a sodium ion battery, it should be a sodium ion rich material. But the anode is a porous material who should happily hold them during the charging and allow them to go back during the discharge process. So what happens when the sodium or lithium or magnesium, they come from the cathode to anode and go back? The anode material, they are not very ruly like school children, that they will come and sit at this place and go back. They hit each other, the volume degradation happens. So anode material slowly breaks. Then when they go back to cathode, they unevenly get deposited. So that is called dendrite growth. So there is a connection happens between cathode and anode and battery life. That explosion happens and other things happens. And most important is this anode material, they interact with the electrolytes and they form a film, which is a barrier. It doesn't allow the ions to intercollect, means doesn't allow to go to and fro from cathode to anode. So these are the major problem what we are facing for practical realization of sodium and magnesium ion type battery, because what we are using as anode material currently, they are not compatible for both type of the new type of batteries. So where we are looking for, like the research community all over the world, like material science and electrochemistry people, they are looking for low dimensional materials like nanomaterials. Like nanomaterials, like everybody can understand, it's like graphene, for which Nobel Prize in chemistry was also given. So they are even monoatomic layer or few atomic layer materials. They have high mechanical strength. Their high surface to volume ratio. Exposed area is very high for the electrochemistry application, and they are highly porous. So this is the new generation material. We need to go for modern development of modern grid-based storage, like for sodium ion battery or magnesium ion battery, which could be at bulkier side, but can serve the purpose of storing solar energy, wind energy, or tidal energy. So now onwards, I will discuss only few slides for our research, what kind of work we are doing. I am mostly from computational material science. So we look into prediction part, and then we collaborate with the experiment, and then a complete product development will be possible, like a database can be generated. So this is one of the work. We got a funded project from Government of India. It is like to develop magnesium ion battery and the anode material. It is like a silicon. It is called silicon boron nitride. It's a material which has both silicon, boron, and nitrogen. It looks like graphene, but it has three kinds of material. So we did density functional theory level calculation to predict whether this material will be good for a magnesium ion battery. The first thing we wanted to see that is it thermodynamically stable, which says that yes. And then the problem is it has affinity towards magnesium. Is the magnesium, when it comes from the cathode side, can it hold or it cannot hold, or if it holds, they agglomerate with each other and forms a magnesium cluster. If they form the magnesium cluster, then the purpose won't be solved. So this is the thorough calculation we did stepwise, and we understood where the magnesium goes, which is the most favorable condition for magnesium to get absorbed to the sheet, that newly designed Si2Bn sheet. And it should not hold it tight, that during the discharge process it should go back from the sheet to the cathode. And for that, and it should allow, when the next and next lithium magnesium atom comes, it should allow accommodate them, so that the dendrite formation should not happen. It should not interact with the electrolytes. All these things were studied, and it is predicted that it is one of the best material if it can be used for magnesium ion battery as a anode material. Next, our department also we studied, like this is also we got a government funded project from Government of India. This is for sodium ion battery. So here also we did both computational, but I'm showing only experimental part. So SiO2 nanoparticles were being used to look at its prospects for sodium ion batteries. So there are there
Just
is
a
another
1 minute reminder, please, Chair.
yes. Okay, so this is what one of the best material we found, and it has high specific capacity. So then the next material we studied, we did with another WTN partner university, where we use BCN kind of 2D nanomaterials, and we studied it's for both sodium and lithium hybrid ion supercapacitors. They behave like their working principle is like batteries. So these are the theoretical calculation been done. So this is my last slide. So what I want to mention that the we need to explore the what was the today's technology. It was yesterday's scientific fiction, that many things we were never imagining, but now it is practically possible. And when we are going for the modern device, we need to look for 2D based or nanomaterial based things. For that, a systematic calculation needs to be performed. How we can guide each other, like academic can give enough input to industries and funding agency, so that a rapid development of modern grid storage can be possible. So at the end, I would like to thank everybody, all the audience, and thank you once again. Thank you.
Thank you very much, Professor. Thank you very much for that. We don't have any written questions in the Q&A function, but just we do have 5 minutes allocated to Q&A here. But as I mentioned at the beginning, there will also be time for question and answers towards the end as well. So perhaps, Chair, maybe one of our fellow panelists might have a question for you, or if anyone does want to just get one in the chat over the next couple of minutes, we'll be able to put that to you as well.
I think we have audience here from different field, so that is expected. So yeah, but thank you very much.
So, Professor, what is your next target of the research?
So we are now mostly also working more for sodium ion battery only, and magnesium ion battery actually industrial cooperation is less because it's still more raw stage, I would say. But lots of industry like Reliance in India and other companies are coming forward. So we are looking more towards sodium ion battery, which is really India's point of view. We need that in India. We also collaborate with one of the WTUN partner, University of Newcastle. Recently, I visited them, so we are working few work together with them also.
I see.
Okay, Prof. Puspamitra,
Yes.
maybe it's very interesting to know that your study on battery, and I think that in a few years after this, there will be a demand towards to electrical vehicles utilizing the batteries, as well as maybe your project is related to the comparison with the commercial battery that already produced by other manufacturer. So what do you think in future, whether is actually feasible for any, not only for the commercial part, for residential as well? Maybe if they are replacing the next generation of battery, as well as maybe with the EV, with the swap technology, which means that you don't have to charge, but utilizing the swap technology, for example. Maybe what do you think about that, Prof?
Yes, yeah, that's a very good question. But the thing is, when it heavy vehicles, they may accept this sodium or magnesium ion battery. But when it comes to domestic use, like you will never want your laptop to be heavier than what you are having now. So lithium is the choice for the time being, or we have to look for new technology. When it comes to sodium and magnesium, that's why I told they need to contribute to grid storage. Domestic help, I think nobody wants to go back. Neither they want their phone to be heavier or bigger or laptop to be heavier or bigger. So that's a challenge.
Thank you. Thank you.
Thank you.
Ma'am, from a user perspective, how do you see the adoption across industries about this new sodium batteries, like devices you have been explaining a lot? Do you see the possibility of its application in mobility, automobiles, or other sectors as well?
Yes, that's actually the major focus for sodium ion battery. What we are having now is towards grid storage. Like when I was showing you the dot curve, no, solar energy, most of the developed countries, if you see, like maybe Malaysia, or I don't know about the scenario in Japan, everybody's roof is now with that solar cells. Like rooftops are solar based energy, they are generating. But once the sunlight goes, even if they have enough, they are not able to store. And with lithium and battery, if you store, then the affordability is a question. So this sodium and battery is mostly directing towards the grid storage. So if we are successful, like fully successful, it will be really a game changer, I would say. But Reliance Industry, they have started using. That's what comes to the news. That's what the market tells. But exactly how far practically it is coming to market, that yet to be known.
And if I may ask a supplementary question to that, this uh, India, we have been talking a lot about RTPV, popularizing its adoption at a household level. Now only that is taking a kind of a momentum from the side of the government. And this microgrids has also been discussed for a decade now, and slowly there are signs of it becoming a reality. Do you think that will also be disrupted by this sodium batteries, ma'am?
Yes, because price is a factor. So if it can be affordable and it is price can be lower, then it will be a better option, I would suggest.
Thank you, ma'am.
Thank you. So shall I stop sharing my slides so that our next speaker can start? So Denise, shall we go for the next speaker?
Yes, please, Chair.
Yeah.
Please do move us on. Yeah.
Yeah. So we can invite our next speaker. Denise, you can introduce nicely to Professor Muralidhar, who will be giving our next talk. I think he will be.
Yeah, certainly I can do that. So thank you very much again, Professor, for introducing our first talk and getting the discussion going. I had a sense that there might have been some more questions there, but we will have some time at the end as well, and hopefully you'll be able to discuss more amongst yourselves as well. So we are moving to our next speaker. We're moving to Japan now, to Shibaura Institute of Technology. And I'm delighted to introduce Professor Miryala, who's the head of the Materials for Energy and Environmental Laboratory at Shibaura Institute of Technology. Muralidhar is going to speak on the topic of revolutionising clean energy and the transformative role of superconducting technologies today. I will just do a very brief introduction, and as I mentioned with the previous speaker and with all speakers, you can find their full biography and more information on our event page. But I just wanted to introduce Professor Miryala is the Board of Councillor, former Deputy President at Shibaura Institute of Technology, SIT, and is the Professor at the Graduate School of Science and Engineering and the College of Engineering also. Professor Miryala's main task there is to transform SIT into a high-rank university, and to accomplish his goal, he's been working and further designing several innovative programs to enhance global initiatives for SIT. These include the Global Project-Based Learning, or GBPL program, Advanced Project Learning, APBL, and PhD Innovation and Innovative program, publication-based internship programs, high school internship programs, and they are all crucial in towards kind of global ranking projects. So that's his international expertise there. From his scientific and research background, Professor has an interest in applications and technology of bulk single-grain superconductors. Professor Miryala has developed a new class of mixed LRE 123 system, which can be used up to 15. So this is getting very scientific here, Professor Miryala. So perhaps you'll be able to do a better job of introducing your work. But he has successfully developed a novel technology to produce RE123 type silver sheath wire on the basis of solid state and liquid phase reactions. Professor Miryala holds several Japanese national and international patents and is a raft of awards, including Young Scientist Project Award, awards by the Government of India, Director Awards, and various other awards of excellence. As we mentioned, he had the incredible Academician of World Award in 2022, and he's also editor-in-chief and editorial board member of several international journals. He's the adjunct professor, visiting professor, and international advisor for several universities worldwide also. So without further ado, I can see that he has his slides ready here to go. So I'm going to hand you over to Professor Miryala from Shibaura Institute of Technology. Thank you very much, Professor.
Thank you, Denise. Can you hear me?
Yes.
Can you see the slide?
Yes.
Yeah, okay, perfect. Thank you very much for your nice introduction. This is Professor Murali from the Shibaura Institute of Technology, Tokyo. Today, I am going to speak on revolutionizing clean energy, the transformational role of superconducting technology. So my educational background is a primary focus on superconductivity, what clearly explained by the Denise, which holds the potential to revolutionize various fields such as like medicine, transport, as well as energy, wind power, etc. The first slide shows that the levitation of the magnet above the NEG 123 superconductor, as shown in the right side, demonstrating the Meissner effect. This phenomena enhanced by the nano pinning is shown in the bottom figure of the left side. As a resultant, it gives the, we will say, the pinning effect. It enables the creation of the strong, powerful magnets. This new phenomena was attracted like human levitation with a high temperature superconductor, bottom right. So in the top one, I received the Pravasa Bharati Sanman Award in Science and Technology, Indian's highest civilian honor from the President of India. The question comes, so why do we need the clean energy? It helps fight climate change, reduces the depletion of the fossil fuels, decrease the reliance on the imports, and promote the better public health. So when you see like what is the fossil fuel, coal, gas, and oil resources, it is limited, and also it is restricted to a few countries. Like if you see the coal, US, Russia, India, Australia, gas in Russia, oil in Saudi Arabia. So in this junction, it depends on the imports of the country rise. No, it's like of course experts' idea is like coal is like another 90 years, gas will be survive like another 40 years, oil Saudi Arabia is the 40 to 50 years, which is the scary thing. Apart from that, since the industrial revolution, human activities have increased the greenhouse gases like CO2, CH4, N2O, and ozone, O3, which persist in the atmosphere for the decades to centuries. That is the one of the issue. You can see like the right side of the figure, human-induced warming already reached 1 degree centigrade, and pre-industrial and global temperature will be rising, going to the 1.5 degree centigrade around 2040 was predicted. However, this the last 2 years, reports indicate that extreme heat and also the loss of Antarctica sea ice, which is clearly like recently reported in the Nature. It's like one of the biggest issue is like to reverse the climate change. Even partly, we need to remove on the order of 2000 gigawatts of CO2 from the atmosphere for the next century. However, what I showed before, like 1.5 is degree centigrade is reaching around like 2040. But however, like this is recently reported in the Nature, the concentrating things, the ratio of the global warming accelerating very quickly. The 2025, 26, they are expecting 1.5 degrees centigrade. In that case, it's very, very important energy sources consideration, like it must be the clean, unlimited, renewable, and volatile and economical is the one of the more important and interesting phenomena right now. Here, what engineers and scientists need to order to combat the climate change. In that case, new technologies that reduce our environmental footprint is the one of the important, such as turn the renewable energy sources and fossil fuel cells, what first speaker is explaining, and also involve the efficient and manufacturing of these technologies. Low cost is the very, very crucial. Further, I can say, like, because I am working for the long term, the superconducting materials, so high TC superconducting technology will be address the impact of climate change. Energy transportation will be done by high TC superconducting cables. You can see like bismuth 223, bismuth 123, MgB2, what I shown in the left side. On the other hand, energy generation and storage will be covered by the bulk Re123 materials and M222 materials, the right side figure. So in this way, just on this, like this is the one of the invention what we made here, RIPCO. In 1986, Bednar Jan Muller found the big discovery in the making the material in superconducting high temperature. Within 1 year, Paul Chu, University of Houston, Y element, he made it like yttrium to replace the Y element, raising the temperature where it becomes the superconductor to 93 Kelvin, higher than the point of the liquid nitrogen boiling. That is the one of the important step. Further advancements came from the substitution of yttrium by the 3 elements, that is the Re1, Ru2, Re3. We made it like more than 60, 70 compounds, 400 neodymium, europium, gadolinium, case more than 15 Tesla. This improvement opened the door using the many industries like making powerful magnets for the fusion, transportation, and also better medical tools, etc. This is like first material performance. We have like designed and ternary superconducting compound of 3 light rare earth elements in the element cell. As a resultant, they found like very high critical current density as 3 Tesla. This is the first material. We found like nano pinning media like gadolinium 211 and also some new particles in this material. As a resultant, the imagining conflict with highlighting the many newspapers and TV's news. They were patented in the US, Japan, and EU, which is the one of the turning point to improve the critical current density at liquid nitrogen temperature at higher magnetic field. And second thing, this is that the new nanometer scale pinning media ranging in size of 20 to 50 nanometers. You can see from the center of the transmission electron micrographs. As a resultant, what happened? The critical current density reached 40 kiloamps per centimeter square at 90 Kelvin. That is the bottom right corner. The remnant JC like akin to YBCO at 77 Kelvin. This breakthrough enabled the levitation of first time in liquid oxygen temperature, which is the one of the another turning point when we use this non-contact bearing point from the space technology and medical devices. Again, this result was appeared in the newspapers and TV. Here in Japan, they made it the patent. Japanese, I also won the award, the Japanese government here. And one more development of the material performance, we have fabricated nanoscale lumilla structures and modulation structures around 4 nanometers, which is close to the coherence length of ITC superconductor, which was shown by like SEM, DFM, dynamic force microscopy, scanning microscopy. Consequently, there was noticeable irreversibility improvement, means that is like around 15 Tesla. Significantly potential for the carrying the 15 Tesla magnets using the material which crucial for the fusion magnets at liquid nitrogen temperature, so that one can make it like low cost, high performance magnets at liquid nitrogen temperature. But however, all these things, we are making this super magnets, but however, the cost is very high. It's like $3,000 for the 3 centimeter magnet. Of course, 3 centimeter magnet, we can make a 3 Tesla superconductor. However, to reduce the price, we successfully developed the batch production of methods for the RE123 type material at low cost, making the world pioneering report such a production. We made it like specific conditions. Eventually, we produced. The achievement has led to securing a new Japanese patent and widespread adoption of my results by the number of commercial enterprises. So something like that. This material development is the crucial. We made it. Just I would like to show some of the applications what they are doing right now. One is the transportation. Of course, low carbon vision and strategy of among the key players of the rail sectors. You can see the bottom figure. Rail sector also reducing a lot of greenhouse gases. As a resultant, the Union of Railways declared that reduction of the energy of the 50% is 2030. That they want to make it like reduction of the CO2 emission, 50% 2030. In the similar fashion, in Japanese government also made it like reduction of CO2 emission of 50% in 2030 and by 75% 2050. In this direction, they are working several things. Then in that case, I can say one is the maglev, magnetic levitation train. This maglev research began in Japan in 1960s. The first experimental maglev train introduced in 1972 at RTRI, which is shown in the left side of the figure, achieved the speed of 60 kilometers per hour, weighed 3.5 tons, and had a capacity of 4 passengers. But the research was well done. We are working like several years in this project. A fully operational maglev train is set launched for the public very beginning 2027, but now they postponed to 2030, covering 360 kilometer distance between Tokyo and Nagoya in just 40 minutes. And also in this way, there is like low TC magnets that in niobium tin magnets, they are using the liquid helium temperature. That is very costly. Then I propose the successful creation of high TC superconducting child maglev vehicle utilizing the batch processed gadolinium 123 super magnets. You can see like just we showed the laboratory like batch production, batch produced the GD123 material. Then suggested that the future maglev system could be operated at inexpensive liquid nitrogen temperature. As a resultant, the world's first high temperature superconducting high-speed maglev engine prototype and its test lines was launched in January 13, 2021 at HGU University, China. This is like a specially fully carbon fiber lightweight body, low resistance locomotive shape, and high temperature superconducting material like RE123 and at the design speed of 620 kilometers per hour. So like that, like one can be, you want to reduce the CO2 emission reduction, the superconducting technology, one of the key. If you go like another is the power transmission and generation, especially when you look like when electricity is transmitted from power station to homes, about 5% of it's lost. They think so, just like 5%, but which is roughly the same as the output of 6 huge power plants in Japan. So if we can think, so now the recent days, many companies, many farmers now they coming to the superconducting cable parts. This is like several companies worldwide, German, Japan, US, Australia. So many companies are coming, like they are making like YBCO cables, bismuth 2223 cables, bismuth 2212 cable, and MGB2 cables. Now the global superconducting cable market size was $300 million at present, but they are expecting reach $700 million end of the 2027. So where they are going to use the superconducting cables, how it will be useful for the CO2 emission reduction? Here, like development of DC superconducting cable. These DC cables are essential to their environmental benefits, especially ability to transmit large amount of power, lighter and thinner design, and high efficiency. Of course, it can be used in several industrial applications, what I shown here. Especially when you look the railway application, because I did like 4 years in this application, the railway. So that's just I want to introduce railway application. Especially railway application, there are 3 key benefits. One is load leveling. Second is energy saving. Third one is CO2 emission reduction. The question comes where the really DC cables can be used in the railways. You can see the Japan railway maps. Red one is the DC cables. So high temperature superconductor, direct current cables are crucial for Japan railways. There is no doubt. With 71.6% of private lines and 36% conventional run relying on them. Additionally, the local lines Tokyo and Osaka operates on DC superconducting cables. Sorry, DC cables. So if you use the DC cables, it's like superconducting technology play the really very important role in enhancing the efficiency and performance of the railway systems. For example, you can see the normal cable is the top one. If you change the quaternary line like bottom, that is the round one, that is the superconducting cable. Normally, no, the ensure the smooth rail operations, a constant 1.5 kV is required. To achieve this, substations are required every 2 to 3 kilometers. What I shown in the bottom, ASS, BSS, CSS, that is the substations. So normally convert AC to DC for feeding the current. Furthermore, by using the DC high TC superconducting cable, there are 5% current losses will be reduced, no substations, and also there is no CO2 emission. So that's why people like Japan. Then they started to looking the how one can be used the superconducting DC cables. First we started the research like prototype. We developed the 2 meters, then followed the 5 meters, 30 meters, 300 meters, something like that. That eventually here is the superconducting technology. You can see the right hand side and left hand side. This is the cross section of the superconducting cable. The main idea to overcome the CO2 emission reduction along with the energy savings. We designed constructed the prototype bismuth, strontium, calcium, copper oxide 2 to 3 cable, 30 meters, eventually 300 meters, and we succeeded the train rain test. You can see the bottom figure, that is the cable is the normal, looks like normal cable, but the liquid nitrogen is passing from one station to another station. This is the right hand sphere. This next generation railway systems, they want to use a year 2050 superconducting railways. That is the model. Normally, they are going to use like natural research energy sources like solar energy, wind energy. It will be generated that directly DC current. They are going to store like superconducting storage units in the nights.
Just a time warning there, Professor.
Yeah, like that we can make it. Then again, I want to show this here something like in the upcoming years, DG HTSC cables are utilized to efficiently transmit renewable energy, particularly solar power, from 365 days sunny regions to the colder countries. A potential cable has been proposed, extended from the India to various world distributions. You can see like red one is the superconducting cable in India. Then that is like, we can say like Rajasthan. Now they are working like Bandala solar project. It is 14,000 acres of the project. I think India is the potential to produce such a energy, which was like this topic was recently I also smallly discussed with our Prime Minister too. So I think high temperature superconductors have potential to play addressing the climate change and supporting the goals of SDG 7, focusing on affordable and clean energy. To make the most of these materials, it is important to understand the excellent physical properties and market them effectively. This will be help bring them to the market at the affordable price and overcome any initial resistance to new technologies. Thank you very much. So,
thank you very much, Professor. It's a wonderful talk. And really, we're feeling very proud that your work is contributing directly to climate change and SDG 7. Yeah, now the questions for the audience. It's really, I was in Japan for 4 years from 2000 to 2005. It's a beautiful country and technologically it is well advanced. But from your presentation, I can understand where they are now, really. Wonderful, sir.
thank you. Thank you.
Prof, maybe if we have someone who actually have some questions to you, but maybe I can start. It is very good, and actually, your contributions, and it's actually from lab to scale. It is something very unique, and then you are actually providing a solutions. I think it's a better works on certain part of, when you are projecting those kind of technology being adapted. So what do you think that by now people is more focused towards to some of the innovations, like you said about the magnetic field, for example, magnetic or superconductors, but they are having such of a very huge project related on that specific materials. So maybe if we are thinking about sustainability for the material itself, what do you think that possible for other worlds actually, like maybe someone from very poor country or low income country who actually would like to do this kind of things, the cost they need to do, and they have to build up their infrastructure, because you have that kind of transmissions. So what do you think the technology can be adapted to that kind of countries?
Yeah, I can agree. At the moment, most of the superconducting companies are well developed and well established in the almost all developed countries. There is no doubt at all. Even though they started Korea and Japan, German, France, then especially like US and Australia also there. But however, what I'm thinking, like if people thinks like DC cables, for example, everybody is, of course, fossil fuels, there is no future. So many problems as a resultant, of course, the sources also depleting. So DC HTC cables can be the one of the more effective, particularly solar power. Everybody is working solar power, no? From like, I think it's definitely there were 365 days sunny regions to the colder countries. It's definitely needed like another after 50 years or 60 years. For example, like we can think something like that, reverse direction. For example, we can see the South Africa, like Thor Desert. If they want to produce like, even though I think developed countries also can help to make it like solar energy there, then automatically transmit to the different countries, even though Japan from there to here or Europe, they can connect. So I think this technology, and now we are in a digitalized society, and also AI, everything like within few minutes in the world. So I think definitely after a certain time will be fixed. But of course, they're developing like in Japan, Sumitomo and Fujikura and Furukawa. They are making the cables, kilometers of the cables. Eventually, they want to use somewhere. There is no doubt. So that's I think it's not a issue in the future.
Yeah. Thank you very much, Prof.
I could not understand one technical part, how it related to carbon dioxide reduction. Actually, that part I was. Is it like less use of fossil fuel that you were indicating, or how it is? Like you told, it's directly connected to carbon dioxide reduction when it is in the railway sector.
Of course, railway normally they are using, but as for the reports clearly indicates, but certain percentage, like they are using like normal power, as well as some cases they are using like coal still, some of the countries. So in that
So
case,
it is not this related to that superconductor. It's like it is
positive.
helping to not use fossil fuel. In that sense, you were telling. Okay, I
Right,
got
right,
little confused at that
right.
slide. That how
And
it is.
also like what I projected, like a small project, like a DC superconducting cable project, what we did here in Japan, especially, they have like 55% of loss. The things,
That was interesting. Very interesting.
then
Yeah.
second thing, like DC cables, normally like we have like several subways here in Japan. Each subway, it is around 32 kilometers. One end to another end. This like more than 10 substations they are using right now, because it's the DC. They must smoothly run, means they must maintain the 1.5 kV. This,
Yes, yes.
so that these substations, if you use the superconducting DC cable, we don't need any substation. There is no decay. That
So
is,
what is there any security features is there if they all go for DC compared to that normal like conventional current? If this DC, all the security features, everything is well taken care in this case.
yes. And also,
Okay.
like now, of course, I moved from as a like deputy president here. I came here 10 years back. Now the still no same like what I presented like maglev. Then even though they are working the DC cables, I am there like 300 kilometer, 30 meters and 300 meters. Now they are working like a 4 to 5 kilometer DC cable for the railway system. They are working like some specific area. So I
So
think,
it is safe.
yeah, it is safe. We already made it like a basic test also. What is like leaked magnetic field and how the magnetic field effect will be in the superconducting cables. One can use it. Then I think that there is no issue at all.
Okay. Thank you. Nice.
Badri, perhaps in that case, I should probably formally introduce you as well, because we haven't done an introduction, so I wouldn't want to
Yes,
to cut
that
down
would
on
be
that
great.
either. So please allow me just to find my notes, and we will do a formal introduction. And thank you so much for moving up the agenda, as it were, today as well. So just bear with me. To our speakers. So, as I said, thank you so much, Dr. Or Professor, should I say, Badrinarayanan, Professor and Head of the School of Management, also from Hindustan Institute of Technology and Science in India. Dr. Badri, Professor Badri is joining us to speak on his topic titled Empowering Rural Communities Through Grassroots Clean Energy Initiatives in India. As with all the other speakers, we do have a full biography and details of the abstracts of today's talks, but a little bit about our speaker. Dr. Badri is an academic and research professional with more than 15 years of experience in academic research, project and program management, entailing startup incubation, startups, entrepreneurship, conceptualization, planning and monitoring of international and national collaborative research and action research development projects across subject areas such as microfinance, poverty alleviation, women empowerment, micro enterprise production, livelihood promotion, MSME clusters, e-literacy and e-governance. Professor Badri has mentored student entrepreneurs and their startup venture ideas through the Hindustan Technology Business Incubator and the Hindustan Entrepreneurship and Innovation Centre also, having mentored student innovators for participation in PAL's Innowa, MMA Business Plan contests, Melting Pot Pitch Fest, Thai Pitch Fest, and other student competitions like the ADB Open Innovation Challenge and so on. He teaches courses on entrepreneurship, strategy, quality management, family business and organizational theory, and supports and guiding doctoral researchers in the areas of assistive technology, blockchain, social entrepreneurship, organizational change and development, MSME clusters, hospitality and healthcare, and finally, hospitality and healthcare sector, and microfinance. So thank you very much, Professor Narayanan, for being here and to start your talk on empowering rural India with clean energy. Over to you.
Thank you, ma'am, for that wonderful introduction. And it is the user side of the story. I would say all the technical talks of today's session are focusing on how this new technologies are being built around this process of achieving affordable and clean energy. And as we are celebrating the International Day of Clean Energy today with WTUN, a quick look at the rural India, which is adopting a lot of clean energy initiatives. India, as we all know, is a very complex terrain with a mix of rural and urban places, as both the speakers have mentioned very clearly. The cost aspect, the affordability aspect, and the technology adoption. These three are the pillars in the process of achieving this noble objective of affordable and clean energy. So India has a great responsibility to achieve this affordable and clean energy. In fact, India has formed the International Solar Alliance to mobilize the international community to work for the solar cause. A quick look at the terrain. 65% of India lives in rural areas. 70 million rural households lack access to reliable electricity. And there is a dependence on firewood and fossil fuels, kerosene, which harms the health as well as the environment. And clean energy is certainly here to empower communities, to improve livelihoods, and foster sustainability. As you see in the slide, a very interesting picture which emerges on the right side of your screen. Hope you are able to see the graph in full because my screen shows the window of the panel. Are you able to see the graph, all the three streams of the graph?
Yes, it's clear for me.
Thank you. You can see a very interesting statistic here, which is an output of a survey with the rural Indian households. The frequency of power cut, the duration of power cuts, how long the power cut lasts. You would be surprised to know 8 hours is quite a normal thing in even in places like Uttar Pradesh, Jharkhand, Haryana. Haryana is experiencing around 7 to 8 hours of power cut, and a lot of households are experiencing this kind of a quality of power supply. Like there is a low voltage, there are issues in terms of the quality of power that is being supplied to the households. The other side of the coin, left side of your screen, which talks about the consumption pattern. Where do how much the rural India spends, and on what do they spend? So this is a statistic given by the National Sample Survey Organization, Statistical Organization, and Household Consumption Survey of India, which tells in the last financial year 23-24, the rural areas spent around 4,000 rupees on consumption, and predominantly they spent on food items than the non-food items. There is a kind of this thing pattern that you see here. What does this mean to us as a consumer? Like the technology which is being developed, where we are talking about the fastest trains which are going to come up in Japan using this new technology, and heavy industries are looking at the alternative energy solutions. Yes, that is definitely going to bring down the carbon footprint. But the last mile households in a very complex terrain like India, which has a lot of geographical barriers as well. There are states which are having mountainous regions, there are deserts, there are places which get flooded at least twice in a year. And the affordability is a big issue in majority of the rural areas. So as you see in the uh, consumption pattern, the per capita expenditure, which is there in the rural households, it's almost the share is 60% of what the urban Indian spends. So affordability becomes a very important issue as far as any technology is concerned for the rural India to adopt. And as we see, 65% of India lives in rural areas. So a technology that doesn't get the subscription of the 65% of Indians is not going to serve the purpose for India to achieve this SDG of 7, affordable clean energy. So this is quite a cross-sectional view of how complex this issue is when it comes to the consumption level. And there are a lot of experiments that have been going on. Thanks to the initiatives at the grassroots level, what we are going to share here are 10 success stories which has helped rural households in India to achieve access to clean energy. So the first this thing, you can see here a rural area is something which is far from the access. At least in some of the places, the accessibility is still an issue. So the non-government organization, the NGOs, play a major role. What we are going to see here are some such experiments which have been done by the non-government organizations, which have forged a partnership across the community, the funding agencies, the technology providers, all them brought together and have catalyzed this change process. So whatever innovation that is going to come in the market, for that to absorb, for that to be absorbed in the rural areas, the NGOs play a very major role in terms of the policy reaching the last mile. The first case study, what we are going to see is of Battigar. This is a very interesting NGO which operates with the village rural households, and especially they started with simple solutions for the pushcart vendors. Some interesting experiment they started with is like somebody who is hawking fruits or vegetables on a pushcart does not have access to power supply. He cannot afford a shop, so he just keeps moving a vehicle which runs on two wheels manually, and he goes around selling whatever product he has, and his market is limited to the availability of power supply. So here Battigar comes with a solution that is a solar powered weighing scale, which is used by the pushcart vegetable sellers and the fruit sellers, and a lighting system which keeps the business going even after the sunlight diminishes. So the problems are unique. Sometimes, as urbanites, we don't recognize that a problem like this exists. But when it comes to rural India, such kinds of complexities are there, which might be something taken for granted in an urban scenario, might still be an unresolved issue in a rural area. They have also come up with a solar powered community kitchen, because one major challenge in a rural area is like the increased reliance on firewood and the LPG. The government has been trying several mechanisms to convert this. Even if you just tune into the news that features India, you would have heard the suffering that happens in the national capital of Delhi because of the stubble burning. The quality of air, the air quality index is difficult. Though we have all the power centers in Delhi, it is very difficult to maintain a sustainable climate, which is leave alone affordable and clean energy. Safe living environment for the citizens is something which is getting endangered. The water is polluted, the electricity, I mean, the air is polluted. The air quality index is really worsening day by day. So the origins are from different places, and one of that is stubble burning in the rural areas. So when this kind of stubble burning is there, what the government one side resorts is to penalize those who burn the stubble, but alternatively we should bring in some solutions which will give them some kind of a alternative utilization of those things, so that they are not getting into this kind of a complexity and complicate the environmental imbalance in a very big way. So this solar powered community kitchens are saving the time of the village women, because women in the villages, they are expected to go around, collect the firewood, and they spend half of their day on that. And fetching water and collecting firewood, it takes a lot of time, and once they come back and cook using the firewood, that creates a lot of pollution, adding to the mist, and the air quality is affected. So all this becomes a problem. So this kind of solar powered community kitchens, you set up an infrastructure, educate the villagers, bring them together through activity based groups, give them awareness, that gives them a kind of a improved health and environmental outcome. And Battigar has been able to do it very successfully in parts of Orissa and Madhya Pradesh. This is a very interesting case study of Barefoot College. We see the title here, the Women Solar Engineers. Sometimes the underprivileged people surprise when you are giving them the technology. The the receptivity is very high when compared even with educated graduates. They might be deprived of formal education, but their brain power is still intact and they are physically active. So they want solutions for their problems. So that gives them a kind of a motivation to get into learning new technologies very fast. You see groups of women here who are very humble, who are very rural in their attire. They have learned very interesting solar technologies and they have become solar engineers. Barefoot College, as it is called, trains village women on solar technologies. They themselves install and maintain solar panels in their villages. This kind of an impact which is created by these women who are trained in the Barefoot College, more than 1,000 villages are electrified. It is, if such experiments are replicated and scaled, that is going to solve the problems across 65% of India. So we need multiplication of such barefoot colleges and women solar engineers. In fact, you go through the research papers on the adoption of RTPV, rooftop photovoltaic cells in India. Uh, one major deterrent to adoption of such technology is availability of skilled manpower to do the maintenance part. Here is one solution like Barefoot College, which trains the community, gives them the ownership. This is your property. This is here to empower you, give you the electrification, a clean energy, and this is how you maintain it. So when you just don't give the fish, but teach them fishing, there is a sustainability. So sustainability is also to be seen from the part of the knowledge sharing, so that the adoption of technology is sustainable for a period of time. All the new technologies which are being discussed in this session must be broken down to such elementary level where it can be given in a box to the people for understanding and adopting the technology. That shall make it more successful. That is an appeal to all the great minds which are working on this technology. The third case study is of CENCON Foundation. As I told you, the rural households are experiencing up to 8 hours of power shutdown every day. Imagine uh, the efficiency of enterprises that are working in rural areas. Apart from agriculture, you see a lot of small businesses, somebody doing a sewing machine, stitching, tailoring, somebody who is selling dairy products by storing them in refrigerators, somebody running a small grinding machine. They require small quantities of power, but 8 hours during the daytime if the power is not there and you experience low quality power supply, then how do you serve your customers? And it is not about the targets of a Walmart or a kind of a conglomerate where one kind of an economy, you have a strategic divestment of your portfolio. If one portfolio, customer segment is not working for you, the other customer segment will compensate for that. This is a very close community. So it's very difficult for them to compensate for the losses of the particular day, and the rates at which the financing is done at rural areas for the communities is very high. So such underserved communities are highly benefited because of such solar experiments, and this CENCON Foundation has empowered the rural households, the rural livelihoods like sewing machines, solar powered sewing machines, dairy equipment and small businesses, which help them to keep the business going, keep them working so that their income generation doesn't stop and it brings them out of the problems that they face in poverty. So this is the case study of CENCON Foundation, which empowers women in small businesses in rural areas. As we were discussing in the previous two sessions by the speakers, the grid connectivity is a challenge in many rural areas, especially in hilly terrains. Connecting them to the grid is a very difficult process. It involves a lot of infrastructure investment. One solution for a complex country terrain like India, geographical terrain like India, is having multiple microgrids which are connecting, powering the smaller areas. Here is one experiment which has been successfully rolled out by an NGO called as Gram Urja. They work in different parts of India. You can see on the right side of your screen the microgrid projects and it can be as small as 9 households to as large as 39 households, from 65 households. From a business point of view, from a macro perspective, corporate conglomerates, they may not find these markets very attractive to invest and serve this customer segment. But there is a necessity and it is dispersed across locations. And if this is going to be the kind of the viability part, then microgrids are going to be the solution for such areas which are otherwise these population is pressurized to migrate to urban areas for accessing this energy requirements, and the children are not able to get educated, the women are not able to get their time off, a lot of problems happen. So this kind of microgrids definitely empower the rural communities, and they have proven it in smaller pockets. And if this is replicated and scaled across different pockets, that's going to empower a lot of people and make this affordable clean energy a possibility in the future. Another is this case study of developing development alternatives. This is again an NGO, development alternatives, which runs experiments across the world. This is one case study from India. India has a very interesting setup. See, when you bring into the cultural context of a village, that encourages a technology adoption, and it also serves the purpose of achieving this affordable clean energy. When you are bringing up a kind of a behavioral change, especially in terms of technology adoption, if it goes against the routines of a rural community, that becomes a difficult thing for them to adopt. Here is one experiment where the development alternatives has formed women groups, uh, and for which Bangladesh was once an inspiration, and it has been highly adopted in India, the women self-help groups, and they formed them as energy clusters. So 30 to 40 women running 6 to 8 livelihood enterprises, they come together to manage a gaushala, that is a cow shelter, which generates biomass. That biomass is taken into a biogas plant, and that facility is helping to supply drinking water. It helps irrigation. It runs milk chilling plant. It runs flour mills. It is helpful in spice grinding. A lot of such use. Also, it helps in protection of the animals. So this kind of thing, which is kind of a win-win, which solves a problem at the same time gives an employment livelihood in the rural areas, has been demonstrated by the development alternatives, where they have given bioenergy to enterprises. This can be really scaled up if it is intertwined with the milk federations, which are procuring milk across the rural India, which is the second largest employer after the agriculture in rural areas. Then coming back to Delhi's issue, where the rice husk is burnt, stubble burning
Just a
causes.
time warning there, Professor.
Yes.
Okay.
I have 1 minute to wrap up.
We're a little bit out of sync now, but yeah, if you could come towards the end, 1 or 2 minutes would be great. Thank you.
Yes. So this is biomass energy, husk power systems, which works with rural households, giving them a technology to handle the rice husk which they generate, and that can be converted into energy. Again, this is women-led solar enterprises. This is like giving a livelihood opportunity for women in rural areas, which promotes the solar product sales. So that kind of adoption, that kind of a point of sale in the villages. In fact, the India Post, the Postal Department of India tried this, but this is a community-based intervention which has been proven successful in several parts of India, especially in Maharashtra. And also there has been successful experiments by a very popular NGO called Pradhan, which spearheaded the microfinance initiatives across India. They have empowered the rural communities with solar powered lift irrigation. Imagine 8 hours of power cut and you have the field to irrigate. and there is no proper power supply. How do you run your pump set? So these are sustainable solar solutions for a rural context. And Greenpeace India has really formed a kind of a beautiful coalition by bringing together a non-profit organization, that is Greenpeace India, the community, an NGO, and the funding agencies to fund solar powered schools in Bihar, which has helped children to study without any difficulty in access to electricity. And finally, the CELCO's solar powered health centers. Uh, Apart from livelihoods and education, health is one major area where the solar energy or the clean energy is very much required. So, in coalition with the United Nations Development Program, CELCO has promoted solar powered health centers, and that has helped in refrigeration of vaccines, which are crucial for maintaining the health of the rural communities. So, though we are talking about telemedicine, accessing healthcare, some physical infrastructure is very much required at the rural areas for some basic services. So such experiments, such necessities can be served through such solar powered health centers. So channelizing the solar energy, the clean energy to rural India can build healthier communities. It can empower the citizen in the rural India, and it can definitely pave the way for sustainable future. All the interesting technologies which were presented by the researchers today have to definitely take this path to overcome the challenges, to mobilize the support from the government and the community, and scale up as micro models for a larger success in a very complex terrain like India. I submit this to this panel, and I look forward that these technologies will definitely be taken to the village doorsteps in India, and we will be able to achieve this dream of affordable and clean energy in the future. Thank you.
Very nice talk, Professor Badri. It's like an eye opener. We talk about science and energy, but this part was kind of hidden from many people. We should know where the real problem is and where to address. Wonderful talk. Thank you.
Thank you, ma'am. I personally felt like you researchers are spending days and nights in building technologies, and you might be happy to know that whatever you are doing research on is making a meaning in several lives across this country. And every time you're doing research, you are making a change in somebody's life who is in the last mile of this country. So thank you so much for doing this for all of us.
Yes, yes, yes. And also, it is not the problem with India. Many other countries are also in the similar situation. Even our neighboring countries are also in the similar situation. So it's an eye opener. So we need to think about that, how the grassroots level energy is required. And if the technology should reach there, then it is the real sustainable growth has happened. That SDG goal 7 is achieved, we can understand that. But yeah, thank you.
Thank you.
But, Madam, can I comment?
Yes, 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 please.
Yeah. Actually, like what Professor has presented, power cuts are very, very common in India. Even though my childhood also, it's of course not much change. However, like the ongoing solar projects across the India are remarkable. What Professor Badri presented, I hope India can achieve a future without power cuts by utilizing the solar energy efficiency. There is no doubt. Thank you very much for nice presentation.
Very nice
Yeah.
presentation.
Thank you, sir. Thank you.
Prof, maybe that were very significant because you have a few case studies across the maybe some of the different locations that you provide a solution for the community. Maybe your projects is relates to agricultural. Then you have some who actually needs for the residents, maybe a small appliance like a small electricity for cooking and other things. And also you are providing a solution for those need maybe a little bit power generations, especially when they are accessing the educations. Maybe do you have that kind of projects, maybe ongoing, or you are planning towards to assessing those kind of utilize some other technologies, not only for the community but for the people or the students who actually would like to access to another another education system by using your projects? Is it any project related on that, Prof?
Yes, sir. That kind of networking possibilities is there, especially in terms of knowledge transfer. This digital divide, the internet connectivity has very much improved in most of the rural areas, which has helped us to get an interaction like how the same technology with which we are interacting now is also available in many villages. Of course, there is a bandwidth issue. There are certain things, but accessibility is improving for the good. But the pace at which it has to improve is definitely something which is more aspirational for the volume that we need to serve. But definitely there are the closer circuits, at least I will say 40 kilometers radius of a tier 1, tier 2 city is having access, better access than what it was 5 years ago. Definitely the bandwidth has increased and the usability is high. And this kind of cross transaction knowledge sharing is possible, especially for students. That's happening.
Yeah. I think that very useful for some of the potential, especially those need the higher educations, because they need to have that kind of facility, like maybe the Wi-Fi, for example, the internet connections, but they need to be powered by this kind of things. Maybe because I think the most prominent one is utilizing a small, innovation on the solar itself to capture, like storing those kind of energy for other purposes. For example, do you have also consider such of the like battery solution, for example, or maybe or direct translation from the solar to the grids, or maybe something? Do you have that kind of projects as well?
Technically, I am not equipped to handle this question, but what predominantly happens is utilization of a technology which is affordable, which can be set up within the constraints of a rural area. So a proven technology at an affordable cost is what most of the such rural experiments are focusing on. But definitely the adoption rate will be higher when the efficiency is better, and the utilization, kind of a translatability of that product is going to be like more useful to the very purpose for which it is brought there. So sustainability part is one major area where we need to work. In sustainability here, I mean not in terms of the environmental sustainability, but the economic sustainability. Like after most of the times, what we experience in such experiments is like after the project funding is over, the technology adoption also stops. The subsidies are over, it is shelved. So that should not be this thing. This should be a kind of a stepping stone to go to the next level. That kind of this thing is what we need to focus as a country now. But I think with the increasing literacy rate and employability of people, that is also possible. People are increasingly realizing that such assets need to be maintained. So yes, as a community, we need to uh, think about this, and we will do our best to do this.
Thank you very much.
Thank you.
Thank you so much for that. I do appreciate that we were slightly kind of out of schedule. I know it's easy for me to say because it's just the middle of my day here, but I'm more than happy to continue beyond the time that we had planned if everyone is still comfortable. And of course, we have Professor Mohammed Fadhil's talk now as well, which I think will tie very nicely into the presentation that we've just heard as well. Thank you so much for your discussions and your input so far. It's great to see an engaged and sort of active panel. And I think it is also complementary to remind us, I suppose, of the role and the potential that higher education institutions have in not only spearheading the research and the technological capabilities, but also the interdisciplinary engagement and, as Dr. Badri said, the sustainability, both environmental and also in economic and longevity terms as well. So it's really really interesting. Professor Mohammed, do you want me to share your slides and then I can share with you? Yep. Okay. I have your
Thank you,
presentation.
Denise. Thank you for helping me.
No problem at all. You'll just need to give me a cue when you want me to advance the slides. Yeah. I'm going to try sharing. Hopefully it will work for me now as well.
Okay, thank you very much. I saw
Great.
it now. Okay, Denise, may I start?
Yes, please go ahead.
Okay, I will try to cut some of the introductory, but maybe as mentioned by the other three panels, my duty here is actually try to make sure that we do actually connecting those kind of technology applications and also the contributions to what exactly what we are doing and we are celebrating. So because since it's actually it's a clean energy day and we are celebrating this every year, but the most important things is what exactly the next, especially towards to the higher education contributions, like in the research and the policy itself. And then this is actually the keywords, the most prominent one that people are actually using as a planetary health, because we would like to make it a kind of adaptations and also the climate resilience for now. Okay, next, Denise. Since we are having those kind of elements, I'm actually stressing that the sustainability is a part of the very good components, especially when we are transforming towards to the action works, because we have in higher educations the R&D, and the R&D is always making a kind of very unique signature and having a kind of transparency towards to the kind of decision making for some of the stakeholders, for example, for the industries, for the government, something like that. So higher education always be in the transformations, always be as a platform to ensure that we can translate these kind of things and make some the interpretation to the stakeholders. So since actually in the climate change and climate adaptation, as well as the kind of clean energy factors that we are actually talking by now, we need to make a kind of prioritizations. What exactly that we need to be prioritized. So in terms of that kind of prioritizations, so every kind of informations, the data, the R&D need to have a kind of data sciences. So I think we believe that whatever we are developing, whatever we are contributing for that kind of sustainability elements in the world of the higher educations, so we need to make sure that it is the best analytic that we can use, and it should be as the assessment, the key assessment for other stakeholders. Okay, next. Since we are actually in the campus, higher education, we are actually grooming from those kind of, maybe from the millennium towards to the alpha generation. So university always is the main agenda when we are transforming the campus itself as a kind of the showcases. So that's why I put the campus operation as the first indicator to utilize the element of the clean energy. So if we are actually providing the R&D, but we don't utilize it in our own campus, it is actually meaningless. So because of that, in the campus itself, it must be translated in terms of what kind of showcases that we can transform in terms of the energy, mobility, and the rest. So, but of course, when we are talking about the clean energy, we reflect and we are actually focusing on the campus decarbonizations. So this is actually one of the most important elements when we are trying to develop a kind of cultural in terms of education itself, the research in terms of making the new elements and what exactly the knowledge transfer. And of course, those professors, lecturers, and researchers in the higher education, they have their own contribution. They have their own roles and functions. So their responsibility now is actually to reach the publics, to make sure that the kind of action works must be transformed in the local community, as well as actually provide a solution to the industry. That's one of the reasons why we are actually developing such a very innovative solution in our campus, in our university, but also we are train our young generation, our students, graduate students, to become as the most important agents towards to the transformations. So believe in terms of the education system, we are not only telling what exactly what to do, what we are actually making them the new generation in terms of talent management. So this is one of the criteria that I think one of the major transformation that we need. Instead of we are developing the innovations and products, we need also renovate our curriculum. The curriculum actually to provide a solution for everyone. Either you are actually as a researchers, whether you are as the advisors or consultants, you need that kind of what exactly the main agenda towards to that kind of solutions. For example, in the clean energy solutions, we need to make a kind of another keywords, another transformations in terms of the competency. We call it as a green job. So the green job is exactly part of the main education and research works that need to be part in our education system. So that's one of the biggest agendas by now. And I think maybe 5 to 10 years from now, the green job is actually really making a kind of another solutions, not only to provide job for the student, but to make sure the student adapt that kind of planetary health or green solutions in their innovations. So this is one of the reasons why we are making this kind of elements. Okay, next. So because of this kind of integration, I do believe that many of us already see this kind of SDG, but SDG will have a time frame of 2030. But of course, when we are talking about the energy transitions, it's until to 2050, for example. But what exactly the reflection that we can make from the SDG, the indicator, usually for those SDG 7, for example, and relates to what exactly the ultimate goals that we are aiming for. Like, for example, in the university, we have the divisions of the living laboratory. So university always thinking as a lab, the living lab, because we are developing a kind of fundamentals values, as well as the R&D for the applications, like in the solar, in the batteries, in this kind of hydrothermals, in the hydroelectrics, for examples, that I will show later on what exactly the innovation been parked in the universities. Of course, it must be related to the SDG. But towards to that kind of things, as I'm very impressed, one of our panels already make a kind of contribution about the woman empowerment, for example. So we have to understand that interlinkages between those gender society towards to the revolutions in the products, in the engineering aspects. We need to ensure that everybody is not left behind. So that's kind of the things that we are making a channelings toward the SDG, and what exactly that we need to make more focus. Like, for example, in the middle of the SDG, we know that not most of the living lab in the university being utilized for, especially for SDG 10 or SDG 8, for example. That must be bare in our mind that this is a kind of goal that we need to commit and must make sure that it is actually interlinkages. So that's a reason that I have put 4 elements towards to this kind of indications, like communities, circular economy, the climate change, as well as the partnerships. So since we are actually in the WTUN, World Technology University Network, for example, so we are actually partnering each others to understand what exactly the contribution for that. Okay, next. Then I would like to highlight, since this is actually been rephrased towards what exactly the contribution. This is one of the main agenda that what we have to do. And in UTM, my university, we are being recognized one of the major contributions towards to our planning and revitalize part of the initiative in terms of the SDG 7 under the renewable energy. And this is a part of what exactly we are targeting for, not only producing the technology itself, but utilize the technology or the energy in the campus. Then it can also be translated towards to what exactly the rules and responsibility by the stakeholders. In universities, students is the major stakeholders, and they need to be together with that kind of achievement. For example, they need to optimize the energy. They need to be saving the energy for certain reasons, right? So whether we are actually provide a solution for them, but if they don't actually making a kind of appreciation on it, so it is meaningless. So both of the infrastructures and the understanding for the stakeholders is very important. So that's a kind of things that we need to embed, not only with the hardware solution, but also the hardware. It means that the people passionate and motivated to do that things. Okay, next. So in terms of the policy for education in Malaysia, we are actually having a kind of a very big agenda in 2025. And most of the universities, not only public one, but also the private university, they are now requested by our Ministry of Higher Education to embed those kind of sustainability around in the campus. So they need to be sustained policy to ensure that what exactly the contribution to the nation. So this is one of the revolution that we are making throughout to this kind of SDG, and what exactly the visions that we are looking for. This is one of the examples in one of the universities, and we are targeting, if for example you are looking toward to the SPA number 1. So this is the what we call that the priorities agenda that I mentioned earlier in this kind of presentations, means that we need to ensure that we are contributing to the net zero carbon campus. So because of that, next, we are actually making a kind of deliberations and understandings towards to these criteria. If you looking toward this one, so we are not work alone. Like we have those professors in electrical sciences, electrical engineering, those actually from the power generations. So they need to be interlinkages with those kind of strategies by sectors. So if you look towards to the policy by the higher educations, they need to be very clear targets and commitment. For example, in 2025, our commitment is to ensure that the GHG reduction is about 15% from our operations. So with that kind of target, what exactly the action works that need to be targeted for each sectors, like for example, for the waste, from the energy itself, from the water and everything. So this kind of target must be very clear enough to ensure that we have a kind of benchmarking. So because of that, we need to make sure that the integration and expertise is in that kind of integration. Because we know that in university, we have researchers, we have professors, we those actually have the subject matter expert, the SMEs. But we maybe lack in terms of financial situation, the budget for that kind of operations. So the major contribution right now is not only because of the products, it's not on shelf, but also not in terms of our curriculum, it's not being understood by the student or the stakeholders. But of course, what exactly the securing grant that we can use mean the financially can be sustained to that kind of initiative. So this is what I'm trying to deliver those kind of elements. Okay, next. So because of this remembering towards to the adaptations and on the net zero energy or net zero carbon, of course, the most important things I just mentioned, the keywords here is the motivation. What motivates us? What exactly the enthusiasms that actually can create those kind of things? Because by only providing a policies, these kind of guidelines to the stakeholders, but if they don't have motivate enough, they may not actually embed in their lifestyle, their daily life, because they may maybe by by force, by the instruction, they will do that things. So in order to adapt that kind of net zero carbon, the things that maybe on in terms of the governance, design, and the budget is actually main factors, but we need to ensure that we need to ensure our talent, the new talents that we are actually provide solutions for that kind of advancements, need to have a very good indication towards to that kind of like supports, the incentive, what exactly the environments for that particular campus. So this is a very, very important to ensure that people will be together in terms of this kind of adaptations. Okay, next. So since we are actually synergizing with the stakeholders, there are few things that elements we need to embed. But of course, in certain elements in terms of the energy, we need to ensure that what exactly the facility, what kind of the expertise that we need to provide. So in the campus, since I said subject matter expert, like for example, in our campus, we have energy managers who actually certified, licensed to do this kind of things before they actually going out for helping for other community, because this is actually one part of the green job competencies and also the gaps that we need to be embed in our curriculum, in our trainings. It's not only just provide a kind of transfer knowledge to the community, but ourselves as a researchers, we need to adapt that kind of new technologies, the new elements, the new the innovations before they can bring out these kind of things to others, to the stakeholders. But of course, another thing that must be embedded in this kind of synergy is to ensure that it must be consistently in our curriculums and educations. Like for example, whether our energy system can be improved for our budgets agenda, number one. Number two, whether this kind of elements in terms of the providing these solutions can provide our economic well-beings. Those kind of actually the campus need to maybe get some other fundings, especially to ensure that it can sustain for their kind of operations. And this is something that we need to embed as well as other kind of facilities. Okay, next. So since we are actually making a kind of things, I do hope that, and I do think that many of us already have a showcases. So this is one of the showcase that we have in our campus, like we call it as a eco park. So this eco park actually have a kind of biogas, means from the food waste generations, and then this also we need some of the leftover that we can utilize for the agriculturals. So we have a kind of tomato, like kind of vegetables to be utilized. Then we also have a kind of microgrid. So this is a mini microgrid in the campus that we are providing for solar generation as well as the biogas. So two kind of resources for this kind of electricity, and then we are monitoring it. So you can see those kind of solar power factors and also the voltage that been generated during that kind of solutions. Okay, next. Next is about this kind of concept that we are utilizing a kind of what we call it as a machine learnings, and this is actually part of these solutions that maybe we are looking toward what exactly the system controllings that maybe we can embed in a kind of sensory, as well as a kind of the devices that maybe is very low cost at the applications. So this is a kind of that what we are doing in our research elements, and this is a very huge potential agenda for the higher education. Okay, next. Another part of things that maybe we are try to integrate here is by providing a solution for like solar, like biogas, like thermal, whatever it is. We need to highlight what exactly the consequences by reducing those kind of dependency on fossil fuel. That's why we have the GSG solutions materials on the simulations. So this kind of simulation been adapted for few of the industries who actually need to be targeted for the reduction of the carbon dioxide. So our university provide this kind of solution in terms of the emissions and making a kind of offsetting, because in Malaysia the carbon trading still not yet been formalized and also been executed, but this is actually part of the solution on the carbon trading. So if the stakeholders having this kind of initiative on the GSG, so they can have to know what exactly the carbon they already been reduced. Okay, next. This is most of the important things, integration about the ESG. I think you know the ESG is nowadays is actually mandatory for the public listed company, especially in many other worlds in the country, but also of course in Malaysia. So it is actually a must. So you need to submit the report on the ESG. So what exactly contribute back to the higher education? So the higher education actually provided a kind of SDG and sustainability values that actually we train our student. We have our own R&D, as well as we also have a kind of experience to provide a kind of solution for them. So this is kind of the integrations that we have to target, and this can be used or utilized by the industry to make sure that they can have a very big agenda in terms of their ESG reportings. Okay, next. This is one of the major contributions from our laboratory. You can see that our prototype development from the micro turbines, exactly this is part of the on-site testings that you can utilize some of the energy. It's not a kind of very technical oriented yet, but this is something like on the fundamental aspect that we would like to check on what exactly the potential energy that we can produce from the free energy, like for example from the water flow, for example from the wind blowing from the aerator pumping station, for example, what exactly the energy that we can utilize. So amazingly, we found that at least 45% of the energy we can utilize. This is something that very important for the industry who would like to have a kind of the optimization of the energy, and this is actually one of the contribution towards to very clean energy and sustainable. Okay, next. Another one is exactly similar to the previous speaker who have that kind of micro turbines. Those kind of elements that we are providing for our obligins, for our villagers who actually need to transfer the water from some level to another level. So we are providing a kind of mini dam, and we can provide those kind of hydraulic jump so that we can, make a solution towards to the irrigation part. As well as the irrigation, we can also turning that kind of water flow and making the energy from the wind turbine. Sorry, from the water turbine. So this is a micro turbine that been developed by our researchers. Next. Okay, next, same that we have, this is a lot of massive elements that we are provide a solution for our villages. Okay, next. Okay, last but not least is, of course, in many other universities, we have a kind of integration and combination with curriculums, especially for the part of the academics. But of course, we also provide a solution for industry. So in Malaysia, who actually need to be as the energy manager or actually working in the energy sectors, they must be licensed or registered in our commissioner, in our act. So by now in our university, we already provide this master program. So when they are actually making a kind of enrollment under this kind of subjects, so they are actually can be requested for licensed or professional energy managers in the field. So this is something that what we are doing for since 3 years ago. and this is still continue until to the micro credential program. So maybe this is part of one of the major contributions towards to the educations and also the professional development. Next. Okay, this is a part of our contribution in terms of the modelings and also part of the products. Okay, next. Okay, next. Okay, this is a part of our e-smart system, and this is personalized for the energy demand that this kind of product being utilized by many energy sectors in Malaysia, including from the government buildings. So this is actually amazingly been produced by our own prototypes, and this is actually been licensed under the collaboration with our Malaysian Green Tech Corporations. So this is a part of the contribution of higher education. So in summary, so we have subject matter expert, we have a products from the R&D, we have a curriculum that can attach together with our clean energy management, as well as the energy provide the solutions. Last but not least is a contribution to the stakeholders by looking this kind of solutions. So with that, I would like to thank, and this is a kind of contribution from higher education. Thank you very much again.
Thank you, Professor Mohd. It's really a wonderful talk. Actually, I would like to thank WTUN for giving us this platform. Like
Yes.
different kind of topics have been discussed. Like one aspect for clean energy is technology development infrastructure, but the other, like what Professor Mulli said, but was discussed by Professor Badri and Mohd sir. It's like a grassroots level of problem we need to address. And the next most important part, its technical hitch was there, but it is good that it has got shifted to the end. Education is more important. Awareness is also more important. And it's very good that initiative has been taken that such kind of courses are being now introduced, and student it's from very beginner level. Problem is there, we need to see what Professor Badri told and what Professor Mohd told, like awareness and stakeholders contribution, everything is needed to make it successful, like if the SDG 7 is to work. And of course, Professor Muralidhar's talk was very wonderful. It was like eye opener. Always we look towards Japan, like technologically. Recently, my collaborator from Australia, he came. He is also from WTUN. He was like one of the collaborative professor. He was telling, you look at all over the world, Japan is silent, but they are 50 years ahead when it comes to new technology, new innovation. That's true. And we came to know about that. This platform really helped all of us. I think we all got benefited knowing what are different aspects actually.
Yeah.
Yeah, education is very important, awareness is very important, and understanding the real problem where the actually problem people are facing and helping and reaching them out. If technology can reach them, it will be a great success to achieve SDG 7. And thank you, Denise, also for giving us this platform. I would like to
Yes.
thank everybody, but everybody can again discuss if any more points are there.
Thank you, Prof.
Thank you.
Yeah. Yeah.
Thank you.
Yeah, thank you so much, and it was an absolute pleasure to bring you all together. When we do these calls to mark these occasions, the primary goal is to bring together and foster collaboration between our WTUN members, which you've all just demonstrated so articulately, and it was wonderful to see the deep research that's taking place, and then also the real world applications, and then ending with the responsibility, I suppose, of our institutions to walk the talk, right? We're teaching these expertise, but then if we can apply it into the communities that we have the most influence on, which is our buildings, our students, our immediate communities and surrounding areas. I think that's where we can make the most impact. And there's a lot of universities in the world, so if they were all doing the same thing, we would be getting quite a long way ahead of ourselves. So I'm going to wrap up the meeting now, if I may, Chair. I just wanted to thank you once again. And Puspamitra, perhaps I can just mention, because you mentioned your colleague in Australia, which of course you participated in the most recent cycle of the WTUN funded exchange program. That is currently live at the moment for applications until the 20th of March this year. So if any of you or your colleagues were considering an application to this programme, you can find information on our website, but perhaps I will just pop it in the chat here as well. And the operational board member for your university is the main contact for that as well. So you can find that information and more on our website. So just doing a little bit of promotion whilst I have you here as well. There is a message in the chat from one of our colleagues at Mindanao State University in the Philippines. I hope you can all see that there. That might be something for you to take up perhaps offline. There was a request for perhaps some review or guidance of like curriculum evaluation of an existing program that they have at MSU. And I'm sure that Johani Balt Andig would be pleased to hear from you, and indeed via their operational board member, Professor Melba Angni, as well from MSU. So if you want any connections with any of our speakers or any of our attendees, please do contact me and we can make some introductions for that as well. But yeah, just once again, thank you very much, Chair and our expert panelists. We will be repeating similar webinars. I think our next one is around zero waste technology. Well, not necessarily technology, but I'm sure we'll have technology element for World Day of Zero Waste in March, and a call for that will come out soon. So please do share that with your colleagues as well. But yes, I am very aware that it's getting very late in some of your homes right now or your offices, so I will allow you to go, particularly those of you who have New Year's celebrations to attend as well. So just thank you very much again, and I hope to see you at a WTUN event in the future. Thank you.
Thank you, Denise.
Bye-bye.
Thank you very much. Thank you.
Everybody. Thank you. Bye.
Thank you. Bye-bye.
Bye. 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 Bye.